This is Geometry, section 8.4, Angles of Elevation and Depression. So, this lesson is really about how trigonometry is used in real-life situations. So, first example, suppose you're standing, looking up at a point in the distance, such as if you're on a boat in the water and you're looking up at a building. Let's say you're on Lake Michigan in Chicago and you're looking up at a skyscraper. Obviously, it's going to be bigger than 90 feet, but we're just using this as an example. So the angle that you draw from your line of sight, so if you're on the boat right here, you can have an imaginary line from your line of sight to the top of the building. We call this, so this is called our line of sight. Okay, and the angle measured from a horizontal line, so you're down here on the boat, if you have an imaginary horizontal line, the angle from that horizontal line up to your line of sight is what we call an angle of elevation. Okay, so an angle of elevation is when you're looking up. It's the acute angle measured from the horizontal to a line of sight observation of an object. So let's say we're looking at the top of the building. Our line of sight is going to the top of the building. So using trigonometry, we can solve for how far your boat is away from this building or from shore or wherever you're trying to reach. So since we now have a right triangle, this is our angle. This side, the 90 feet, which is the height of the building, is opposite. And we're solving for the adjacent side, this x, how far the boat is from the building. So adjacent and opposite means we're using tangent. Our angle is 10 degrees, so tangent of 10 degrees equals our opposite, which is 90, over x, which is our adjacent. And just like we learned in the last section, when you've got your variable on the bottom, that variable is going to equal the top number divided by the tangent of 10 degrees, or whatever angle, whatever trig function you have over here. So I'm going to type that in my calculator, 90 divided by tan 10 gives me 510.4, so we'll just round it to 510 feet. Okay, so the boat would be 510 feet away from the building. Okay, so another example is when you're at a point high above your surroundings, such as in an airplane or you're on top of a building this time, and you're looking down at something below you. So the angle that your line of sight, so if you're up here in this airplane, this is now your line of sight looking down. So the angle from your line of sight in between a horizontal, so we're always going to measure from a horizontal line, never a vertical line. This is never going to be our angle of depression, which is what this one's called. Okay, so you're never going to measure from a vertical line. It's always going to be from a horizontal line down or a horizontal line up. Okay, so angle of depression is when you're looking down. It's the acute angle made by the line of sight to the horizontal. Okay, so you have this imaginary line of sight, you have this imaginary horizontal line. Okay, and note that an angle of elevation is really the same thing as an angle of depression, because if this is 32 degrees right here, if someone were down here at this airport tower and they were looking up at your plane, their angle of elevation would be the same as your angle of depression, because this horizontal line would be parallel to this horizontal line. So these two angles would actually be alternate interior angles, and they're the same. Okay, so again, you're always measuring from a horizontal line, never a vertical line. Okay, so we can solve for this x as well. So if we know that the plane is 12,000 meters in the air, this would be opposite, and x is the adjacent. So we can answer this question, how far is the tower from a point directly beneath the plane? Or what's the horizontal distance from the plane to the tower? So we would set this up, again, opposite and adjacent is tangent. So tangent of 32 degrees equals our opposite, 12,000, over our adjacent, which is x. When the variable's on the bottom, we're going to take this number divided by this number. So it's going to be 12,000 divided by tan 32. So I get 19,204 approximately. So x equals 19,204 meters away. Okay, and the rest is just more examples. So if you've got a kite with a string that's 150 feet, so this is the string of the kite, it makes an angle of 45 degrees with the ground. assuming the string is straight and it's not bunched up or anything, how high in the air is the kite? So now this is our opposite. This, the length of the string, is now our hypotenuse, because this would be our right angle right here from the kite to the ground. So opposite and hypotenuse is sine. So now we've got the sine of our angle 45 equals x, the height of the kite, and 150 for our hypotenuse. So to get the x by itself, we multiply by 150. When we type that in our calculator, we get approximately 106 feet in the air. Okay, now solving for an angle. We learned this in the last section. So now if I've got this is x, I'm trying to figure out what my angle of elevation is. I know the height of the tree and I know how far I am away from the tree. So this is my opposite. 10 is my opposite from this angle. This is my adjacent. So adjacent and opposite means I'm using tangent. So tangent of x is going to equal our opposite, 10 over our adjacent, 17.3. And remember, to get rid of tangent or to undo tangent, we take the inverse tangent of both sides. So x is going to equal the inverse tangent of 10 over 17.3. So that's what I type in. Second tangent, don't forget to hit the second button because we're using inverse tangent. 10 over 17.3. I get about 30 degrees. 30 degrees. Okay, from the top of a fence, a person sights a line on the ground at an angle of depression of 24 degrees. So that also means that if the lion is looking up at you, hopefully he's not, 24 degrees would be his angle of elevation. So if this is x and you are 4.2 meters above the ground, this would be your opposite. This would be your hypotenuse. So opposite and hypotenuse is sine. So we're going to say the sine of 24 equals 4.2 over x. Again, when the variable is on the bottom, you're going to have to take this number divided by this number. When we plug that in, we get about 10 meters. So you're 10 meters away from the lion. Okay, and last one, if you've got a 300-meter cable attached to the top of an antenna, the angle of elevation from you on the ground to the top of the antenna is 15 degrees. How high is the antenna? So you're trying to figure out how high this antenna is. So opposite over our hypotenuse means we're using sine. So sine of 15 degrees equals x over 300. We would multiply both sides by 300. So x is going to equal approximately 78 meters when we type that in our calculator.